Hi, everybody. We're going to now part two of section 2.5. And this is some more just examples. But this, we learned chain rule, we learned product rule, we learned, quotient rule, all that. Now we're going to do some problems which combine all these. For example, the problem in front of us, we basically have a product. We're multiplying this function here. Oops. Multiplying this function here times that function there. So that's my f and that's my g. That's my f and that's my g. And now I'm going to take I'm going to do the product rule, but within the product rule, I'm going to have some chain rule. So first I'm going to do the derivative of e to the 3x. So e to the 3x, the outer derivative is e to the 3x times the inner derivative, which is 3. Again, that's my outer, that's my inner. And and this whole thing here is my f. Oops, this whole thing here is my f prime. I want to use a different, I want to use the, oh, sorry. This is my f prime. Now, I multiply that times my g, which is ln 5x plus 7. So that's my f and that's my g. That's my f plus e to the 3x, e to the 3x times 1 over 5x plus 7 times 5. Now, where did this come from? So this here, e to the 3x, that's my f. And this whole part here is my g prime. And that's my outer, and that's my inner. So this is it. That's our answer. E to the 3x times 3 ln 5x plus 7 plus e to the 3x times 1 over 5x plus 7 times 5. And that is the truth. Okay, let's do another problem. So again, so ultimately we had this is a product rule problem with a chain rule, but we needed chain rule to get our f prime and our g prime, we had to use chain rule. So it's a product rule and the chain rule was within the product rule. Let's do some other ones. Let's look at this here. We are going to. Here's a nice, fun little problem. This is a chain rule. Ultimately, it's a chain rule because I have this big blob raised to the 4th power. But within the chain rule, when I go to get the inner derivative, I'm going to have to use quotient rule and product rule. So let's take this apart piece by piece. So first of all, z prime is going to equal 4 times 3t cubed over e to the t times t minus 1 raised to the 3rd power. Now I need the inner derivative. Now the inner derivative, if you notice, it's a quotient, but the numerator of the quotient, not the numerator, the bottom one, the denominator of the quotient has a product in it. So this is going to be the following. It's going to be, now I'm just going to call this part my f. I'm going to call that part my g. My g is going to have product in it. So let's just do this. So first we have f prime, which is 9t squared, times g, which is e to the t minus 1. That's my f prime. That's my g. Minus f, which is 3t cubed. Now, here's what I'm going to have to use. To get my g prime, I'm going to have to use the product rule to get g prime. So to get g prime, I'm going to say e to the t prime, which is e to the t, times g times t minus 1, and oh, it's plus e to the t times 1. Now, I guess what I'm going to do is I'm going to call the e to the t, I'm going to call that h, I'm going to call that j. So this is h prime j and h j prime, because j prime is just 1. And all of that, all of this is going to be over g squared. So it's e to the t times t minus 1 squared. By the way, there's no difference between the round brackets, round parentheses, and square brackets. You know, sometimes in algebra, you have a difference. Yeah, you have like interval notation and this and that. I'm just using square and round just for contrast. It makes it easier. It makes it a little bit more visual. That's it. Well, that's it. We're done. So the answer is the derivative is, drum roll please. Well, this whole mess. Okay. Don't try to simplify it. Here's a nice fun example. Y is equal to 5x plus 4 to the negative fourth power. So y prime is going to be, now the outer derivative is going to be negative 4 times 5x plus 4 to the negative fifth power. And the inner derivative is going to be 5. That's the answer right there. Again, that's my outer. So I'm looking at blob to the negative fourth power. So it's negative 4 times blob to the negative fifth power. And that's my inner function is 5x plus 4. So my inner derivative is 5. Let's do another nice one. Here we go. Let's just put it right here. Example. Oops. So we have y equals x plus 2 over x plus 9 over x plus 1 to the ninth power. Well, this is a chain rule, but within the chain rule is going to be a quotient. So the outer derivative is going to be straightforward. Y prime is going to be 9 times this whole big blob to the eighth power. So that was fine. That was straightforward. In other words, it didn't. No matter. In other words, no matter how hideous this function is or isn't, doesn't matter. It's going to be straightforward. But for the inner derivative, we're going to need quotient rule. The inner derivative is going to be f prime g, which is 1 times x plus 1 minus f, which is x plus 2 g prime, which is 1 over g squared. And again, that's my f prime, that's my g, that's my f, that's my g prime, that's my g squared. Now, of course, what's f and g? I never told you what f and g was, but I think from context you could probably figure out that that's f right there, and that's g right down there. And we are good to go. I want to show you a problem that appears in my Open Math Lab. It's actually one of the homework problems. So I'm going to switch cameras now, and I'm going to share my screen. And here we go. So, oh, this is a okay. The radius of a circular oil spill is after t minutes is given by R of t is equal to square root of 16t. And R being the radius and t being time, t minutes. Find the instantaneous rate at which the radius is growing after 28 minutes. And instantaneous rate changes, that's derivatives. So let's switch over to the other paper, and I'm going to work it out for you. So I'm going to switch my camera. Okay, so here we go. R of t equals the square root of 16t. Now, R prime now this is equal to 16t to the 1/2 power. In calculus, it's easier if you write, sometimes if you write with exponents. Okay. Now, R prime is going to be equal to 1/2 16t to the negative 1/2 power times the inner derivative, which is 16. Because the square root function is my outer derivative, the 16t is the inner derivative. So again, that's my outer, that's my inner, that's my outer derivative, that's my inner derivatives. Really just get this focused. And now let's just make this look a little bit nicer. So this is equal to 1/2 rad 16t times 16. And that cancels right away. That becomes an 8. But I could do a little bit more because the square root of 16 is 4, so it's 8/4 rad t. It's 8/4 rad t, which is equal to 2/rad t. And now we wanted to know, what did we want to know? We wanted to know when we want to know at 28 minutes. So the question now is, what is the rate when t equals 28? So when t equals 28, so r prime of 28 equals 2 over the square root of 28. And for that, I'm just going to use a calculator. I don't know if you can see the calculator on the screen, but I get, let's see, 28. But I could reduce it even further if you really want to. And that, actually, I'm going to reduce this further just to show, just to do a little algebra. Because this is 2/2 rad 7. So it's 1/rad 7. All I gotta do is go to a calculator and figure out rad 7 square root, and then reciprocal of that is 1033. Let's see what we got here. Let's see how many decimal places. Okay, now I'm gonna go back to sharing my. I'm gonna go back. So I have here. Let me just we still on this. Still recording. So this is approximately. I just had it here a second. 0.33796. I mean 377. Not sure how. And now I'm gonna go. Now I'm gonna go back to sharing my screen. Let me shut this over. Back to sharing my screen. And let's get back. Okay, here we go. And now let me switch cameras so you can see what's on my screen. I'm just going to type in, give your answer to 3 decimal places. So we just want 3 decimal places. With at least 3 decimal places. I don't know what they mean by that. I mean rounded to 3. Well, it's something. It says with 3. Let's see what they want. If this is not good, we'll round it. Well, let's just see if this is acceptable. Yep, that's all they wanted. Interesting, and because it didn't say round to 3 places. It just said with at least 3 places. So I just took the first 3 places. Even if I was rounding, I would have rounded it up differently. Anyway, these are some very nice, lovely problems, and it's been loads of fun. Chain rule, as I said, is extraordinarily important for calculus. Already we see how valuable it's been. Let me just unshare here. We already see how valuable chain rule is, and that's it. It's been absolutely lovely, and I will see you next time. Bye.